Welcome to Lesson 13, the second lesson in the second unit, unit number 2. In this lesson, you are going to learn how to distinguish between a physical and chemical change, recognize a reaction as being endothermic or exothermic, identify the delta H or heat of a reaction, and write the heat term into a reaction. Make sure you copy the differences between chemical changes and physical changes into your notes.
Hi, class. Okay, now I'm going to teach you how to define a chemical change from a physical change. The first thing you need to know about a chemical change is that the formula will always change. The second thing you need to know about physical changes is that physical changes formulas never change. Okay, now that we know what chemical and physical changes are, we're going to define them. Notice here that these chemicals are not the same as this chemical. So now we know it's a chemical change. The second one has the same formula. So now we know it's a physical change. These formulas are also the same, so it's a physical. These, however, are not the same. These are not the same. And these are the same, so it's a physical. Identify which is a physical change. Physical changes don't have formula changes.
The physical changes that we are going to look at are called phase changes. Every time a phase change, the potential energy changes as the position of the particles change. For simple phase changes, adding energy causes the potential energy to increase and the entropy, also known as the randomness, to increase as well. While removing energy causes potential energy to decrease and entropy or randomness also decreases. It is important that you are familiar with the terminology of all 6 phase changes. Remember that in chemistry, we often call melting fusion. Also, the phase change that goes from a solid directly to a gas is called sublimation. You must add heat energy to cause something to sublime. So this is endothermic. So fusion, vaporization, and sublimation are endothermic phase changes, while condensation, freezing, and deposition are exothermic. Looking at the phase changes from the reactions earlier, we can determine, based on the phase of matter, whether the reaction is endothermic or exothermic. In the first reaction, we begin with a liquid and we end with a solid. In order to turn a liquid to a solid, you must remove heat. So this phase change is exothermic. In the next reaction, you can see that we begin with liquid nitrogen and turn it to gaseous nitrogen. To change a liquid to a gas, you must add heat. This change is endothermic. The final phase change is that of dry ice. Solid carbon dioxide is called dry ice. When it sublimes, it turns to a gas. You must add heat to change a solid to a gas, so this sublimation process is endothermic. So thanks to Sydney, by now you should be able to justify if a property represents a chemical or physical change. So heat changes can be endothermic, where heat is absorbed into a system, or exothermic, where heat is released from a system. When heat is endothermic, the heat term is always going to be positive. It will always occur on the reactant side or the left of the arrow. It represents what's put into the chemical or physical reaction. When something is exothermic, the heat is always negative, and the heat term is always written after the reaction arrow to show that heat is lost or it's coming out of this change process. So the location of the heat term in an equation can tell you if something is endothermic or exothermic. Since endothermic means heat is released and our heat is a positive value, the heat will always be on the reactant side or come before the arrow in a reaction. So when we see here, when I have solid water and I add heat to it, I can produce liquid water. This is called melting. In chemistry, melting is also known as fusion. Now, for the exothermic process, where we undergo freezing, we begin with liquid water and we remove heat from it. But since we're not allowed minus signs in chemistry, we're going to move the minus heat to the product side of the equation. So when I have liquid water and I freeze it, I can turn it into solid water and heat that is released so it appears after the reaction arrow. Let's see if we can put this together with some chemical changes. You will need reference table I. Reference table I gives the heat of reaction, or the difference between the potential energy of the products minus the potential energy of the reactants for many chemical reactions. On this table, chemical reactions with a negative value are exothermic, and chemical reactions with a positive value are endothermic. Here, the top reaction is the combustion of methane. Notice that the delta H value is a negative number. If I wanted to write the word heat or the heat term in this exothermic reaction, the word heat or the value of heat must appear after the arrow or on the product side. Reference table I gives us the delta H or change in heat for many reactions. And so when we look for the synthesis of this compound, C2H4, also known as ethene, we can see that reference table I tells us the delta H is positive 52.4 kilojoules. So if we needed to write the heat into this reaction, it should come before the arrow, as you can see here. This idea should remind you of a very general rule in chemistry. Making bonds releases energy, as the particles tend to gain more stable, lower potential energy, more like noble gas electron configurations when they make bonds. Breaking bonds requires energy. Energy must be absorbed. But remember that chemical reactions are quite complex. Most chemical reactions involve both bond making and bond breaking. So when we look at this image here of the chemical reaction for the combustion of methane, you can see that we have to break the bonds in the reactants before we can form new bonds as products. Now, table I goes and shows us that this reaction, the very first reaction on table I, has a delta H of a negative 890.4. So overall, this chemical reaction is exothermic. Heat would be written on the product side of this reaction. Look at the placement of the heat term of this reaction. Does this qualify as endothermic or exothermic? In this reaction, notice how one substance, diatomic chlorine, becomes two separate chlorine atoms. Find the dissolving process for ammonium chloride on table I. Dissolving in water is found on the bottom third of reference table I. Use the delta H to figure out if the reaction is endothermic or exothermic. So by now you should be able to recognize if a reaction is endothermic or exothermic, identify the delta H for a reaction, and write the heat term in a reaction.
That's the end of the video. See you in class. Bring your questions with you.